Okay, we're going to start off by working on one of the 8 horsepower motor. This one is a GE, but the A.O. Smith motors are virtually identical. I'm going to go through a little more detail on this motor, and then the other motors will be more edited for time. This is the basic technique on how you remove the sheave. You can use a board with a hole in it. I use a couple of clamps because I don't have enough hands sometimes. That allows you to compress the spring, get the spring out of the way, which allows you to remove the clip on the end. There's different clips that were used. Most of them had a regular external snap ring that you do like this. The ones from some of the greenies and the brownies had a spiral type clip, and the very earliest motors, the Franklin motors, had a large nut on the end of the spindle shaft that you'd remove, and you'll see that in the segment on the Franklin motor. When you go to release this, you need to be real careful so that the spring doesn't fly up and hit you in the face. Recently I did have a spring get away from me, hit me in the chin, but it didn't cut me, luckily. You might have to use a penetrating oil to help you get the sheaves off, the sheave halves. You might have to scrub the shaft a little bit too. There could be enough gunk there to make it harder to take off. You have to access the set screw for the fan sheave through this gap. It's a regular Allen wrench. I think every single one I've ever seen has been a 5/32 inch size set screw. I take the screw completely out so that I can inspect the end of it. If it doesn't have a serrated end, I replace it with a brand new one. The serrated end lets it really get into the cut into the key. You can see I squirted a little more penetrating lubricant in there to allow it to soak, make it a little easier. Dust gets in there and makes it hard to get apart. You might have to start it by prying it like this with a large screwdriver. If that doesn't work, you can go to a pry bar like I had to here. If the sheave just won't come off at all, you can just leave it there and take care of it, pressing it off with your bearing press. With a little bit of soaking, that will typically come off. If you do this, make sure you don't damage any of your fan blades. So there's the key. You can inspect the key, make sure there's no burrs on it, make sure it's not bent. There should be a spacer on the shaft that keeps the fan sheave from rubbing against the housing. Now, before I take a motor apart, I always like to make index marks on it, just like this. And that way I can have the housing aligned the way it started off. Getting the bolts back into those tiny little holes all the way across the housing can be pretty tricky, even if you have those marks. On this motor, we need to access the on-off centrifugal switch. A little access cover here. Loosen all 4 bolts. You don't have to take them completely out. Just take one completely out. This lets you see the on-off switch is powered as the motor turns. It disconnects the capacitor from the circuit. This is usually not too dirty in here since it's covered by the cover. But you can check the contacts to make sure they're not corroded. If the motor was in a very damp environment, it could be. There's a couple of leads underneath this switch. I like to take a red magic marker and just mark one lead and its terminal the same color so that I can get them back the same way. doesn't seem to matter how fast that it works either direction, but one lead will be a little bit longer than the other. In this way you're not going to have to fidget quite as much to get it back together. I use the pliers to pull them off. If this is your first time taking a motor apart, you can always use a digital camera and take pictures of each part in place and make sure you get things back together right. The next step is to take these two little springs off. I use a pair of needle nose pliers again. When you see your own motor, you'll see they come off pretty easily. Usually they come off a little easier than they are right here. There you go. Two. Make sure you put them away safely. One of these fell off the bench and I had to look for it when it came time to put the motor back together. Pry apart the bracket to get that centrifugal weight out. I just pry with the screwdriver just to separate the wings just a little bit. Comes out pretty easily. So that's the weight that opens and closes the switch. Fumbled fingers the day I was working on this motor. Now we have to take out that nut that connects that bracket to the shaft. I kind of hold one side of the shaft still so that I can unscrew the motor. Takes care of everything you have to remove at this point. So it's time to start loosening the 4 case bolts. Sometimes they can be corroded. You might have to use a penetrating lubricant at the end with the threads. In general, they come out pretty easily. There's 4 bolts in the motor, any of the motors I've worked on. I typically work in this small space here, doing my headstock work. I have all the tools I need right in the same location. Earlier footage you saw me in my woodworking shop, my hobby shop, but it's farther back from the street, not as convenient for shipping and receiving headstocks. Okay, now there's 2 more bolts to loosen. That's for a retaining bracket that holds the bearing against that back plate, so we have to loosen those. Some motors have this type of retaining plate, but they're more often found in the front on the fan sheave end. When you're working on the motor, just take your time. I can do it start to finish in an hour. Taking the motor apart, inspecting everything, cleaning it, putting on new bearings, getting it all back together. But if you're doing it for the first time, you might take 2 or 3 hours. Just take your time, do it right. Better just to open it once, close it once, and have it right. pain to have to open it up a second time just to change something, put something on. I forgot. Here I am just knocking the back plate off the bearing. You can see the bracket that was holding the bearing. Both of these bearings are bad, needing replacement. You can see how dusty it gets inside. Before we put it back together, we're going to clean everything up real good, inspect all the wiring. I'll knock the front plate off. This is the end that often has the bracket that holds the bearing. Okay, that spacer is an important little thing. It's sort of a spring-loaded spacer to give the bearing a little bit of leeway, front and back. If you're going to vacuum like this, make sure you count it for all your little parts. You don't want to suck up a small part into your vacuum. I've done that before. I just try to get all my small parts out of the way at the back of the bench, safe from the vacuum. I've recently changed my shop vac to have a much smaller hose, smaller attachment, so I can get into cracks and crevices even better. So you can see I use a toothbrush to help get into a lot of little areas. Even a screwdriver can help you reach areas, screw up the dust so you can vacuum it out easier. But I go ahead and just get all the vacuuming done early before I change the bearings, before I start putting it back together. And after vacuuming, you can wipe everything down with mineral spirits to make sure you don't have any sap and gunk. There's often grease that's squirted out of the bearings or leaked out of the bearings over the years. So in the bearing cavities, you'll find a lot of sticky mess, the grease combined with sawdust from the years. I know this part isn't too interesting watching me clean, but it's a real important step. I feel when you have the motor open, you might as well start it off fresh. Enough sawdust is going to get sucked back in there first time you use it. There's a lot of cracks and crevices in these sheaves. You get a combination of dust from the disintegrating belts and of course from sawdust and the oil. You always oil this sheave every 5 hours of use, and so some of that oil squirts out into these areas and mixes with the other dust. So this is why a brush like this is very good to help you get into those crevices for cleaning. And inspect your sheaves closely, make sure you don't have any cracks or dents. I had one of those sheaves recently that was worn from wobbling and had to replace it. I had another fan sheave that had 2 cracked fan blades. So it does happen. I even vacuum off the spring. The smaller parts I'll just wipe off with mineral spirits and a shop cloth. I don't want to accidentally suck them up into the vacuum. Again, we're showing more detail on this first motor than on the last 3 motors that I'm going to be showing. So even if you don't have this particular motor, watch the sequence, because you won't be getting quite this much detail on your own motor. this motor I put first because probably 80% of the Shopsmiths out there have this motor in it, or the A.O. Smith motor. Okay, now I'm showing you there's a little clip that retains the bearing. So the bearing is held at the back by this clip, and it's held at the front with a shoulder. And it's also held in place against the housing with that bracket. So this bearing doesn't have any room to move around. At the front, take off the spacer if you haven't done so already. Okay, here I am with my 12-ton bearing press, pressing on that back bearing. Just a short little press. Big box of used bearings underneath there that I'm going to end up selling for scrap metal at some point. Okay, this is pressing off the front bearing. So if you had a stubborn spacer, you can do this, and the spacer will come off with it. See how gunky that was on the back? Okay, now we're ready to press on a couple brand new bearings. You can get the bearing number off of the bearings that you remove. There are different bearings for the different motors, so I don't want to give you bearing numbers because your motor might have something different. Over the years I've found about 4 different bearing numbers used on various Shopsmith motors. Before you press this bearing on, make sure that plate is in place. I put the bearing on and then had to take it off to put the plate back in. Easy to forget. And when you're pressing, make sure it doesn't get stuck between the bearing and the shoulder or the clip. I'm holding it up there so it doesn't get caught in there. Always inspect your bearings to make sure there's no gap between the clips or the shoulders and the bearing. Make sure they're in the right position. So now I'm putting that retaining clip back on in this case. I don't really think that bearing could go anywhere, even if the clip was missing. But that's how the manufacturer built it. So I'll put it back on after cleaning everything. So now we're ready to put it back into the housing and tighten up that bracket. Hold it correctly. Just have to align those holes to where your bolts will reach through. You might hear my dog whining to get out. It's a cold January day, and I had my heater running. You can hear the heater in the background, and I had the door closed so the dog couldn't get out. So we just snug that down too. Now we're ready to reassemble. So it's best to go ahead and get your registration marks approximately right so that you have your wires ready to go through the correct holes. So here I'm feeding the capacitor wires back through. There's a rubber grommet that they go through. You want to make sure your wires don't interfere with the rotation or with the switch. It's easy to get your wires in the wrong configuration and it'll wrap around or get broken first time the motor is turned on. Now at this point I should be putting that spring washer on top of that bearing. And I remember this, I did this without that spring washer and had to take it back apart. And I've done a lot of motors, it's still easy to forget a step. I was kind of focused on getting this video made. Okay, so I've tapped the housing back together. You'll see me align the registration marks. Using the mallet to move the case around. Get it cinched in so that I can start feeding the bolts through. Get the bolts started so they don't fall apart. On the first one you'll find out if you've got those registration marks in the ballpark. This motor's good. The threaded end is molded into the front part of the housing. You'll see on one of the later motors you actually have to deal with little nuts at that end. And this motor has hex-headed bolts, much easier to deal with than screw-headed. So I'm getting a couple of the bolts started. Okay, now they're all in place and cinching everything up. I want to make sure there's no gaps, front or back. Everything's cinched evenly and tightly. That way your bearings are supported correctly, front, back. So no gaps. It's good and tight. So now it's time to put, checking to make sure that it turns freely. Now it'll be time to put back all those centrifugal clutch parts. First is that bracket with its bolt. That bolt goes right into the center of the shaft. The end of the shaft is machined so that it fits right into that bracket just a certain way so that it's centered and that the bracket can't spin on the shaft. You'll be able to see it on your own machine. It's kind of a small area. Your fingers get in the way of each other. Again, just take your time, be patient, take a break if you need. If you took pictures and taking it apart, you can consult those pictures for putting it back together so you get everything in the right orientation. So that weighted panel goes back in between the brackets. Again, you'll have to spread the wings just a little bit so you can push it back down in. It fits into two little holes. Once you have it dropped back in, check it to make sure it rocks back and forth freely. If you spread the wings a little bit too much, you might have to use a pair of pliers like this to close the wings back so that doesn't fall off when the motor runs. I don't have to close it back often like this one. So there it is, moving freely, centered on the shaft. Now we have to put the springs back on. Use it with the needle nose pliers like before. So now that's that sound you hear when the motor turns off, turns on. Some people wonder what that clicking is. Ready to put back the switch. There's a bracket that supports it. Again, I marked one of the wires so I know which one came off of which terminal. Doesn't seem to matter. I've tried reversing them. doesn't seem to affect things at all. But like I said before, one wire's a little longer than the other usually, so there'll be less of a strain on the wire to get them back right. And again, make sure those wires can't interfere with the rotation. So now this is the tricky part, holding everything in, feeding that bolt down through everything. You're going through the bracket, through its supporting bracket, and then down into the case a little. And everything has to be aligned correctly. My hands aren't real big, but they still get in the way of each other. A person with real big hands would possibly have a lot of trouble. Here we go. It's clicking. It's centered on the rotation. You don't want it slipping off of that. So that looks like that'll work fine. The contacts were clean. Doesn't wiggle around. So everything looks good there. So now I've sealed up that area and ready to test the motor. Make sure I got everything back together right. It sounds really good and clean. I do this before I put the sheave and everything back on. That way if I have to reopen it, I don't have to take quite as much off. Okay, now we're sealing it back up. Make sure you're safe with electricity. Talk to people if you're not sure how to do things right. Just really treat electricity with respect. You can get hurt in no time. My dad was an electronics technician, a very good electrician, so I learned a lot growing up watching him and helping him. And he got shocked, he got cut. I have too, even being careful. Okay, cleaned the spacer. Put it all the way on the shaft first. Cleaned the key. Want to make sure they're bottomed out on the bearing. You don't want to tighten up on that key and then have everything shift closer, because you might end up with a rubbing fan sheave. So if the set screw looks fine, you can clean it up. Otherwise, get a brand new set screw with a serrated end. I like to put fresh Loctite on it. It's a pain to have to take the sheave off and do a lot of that work just because of a loose set screw. So get the set screw started, get that fan sheave in place, tapped down firmly, and then tighten it up. You have to line it up so it slips over the key. Need to be firm but delicate too, so you don't damage something. So I gave it a good spin, make sure it didn't rub. I have it pushed down all the way onto the spacer, pushed down with the key. So now I give it a real good amount of torque, so I know it's biting into that key. At this point I like oiling the shaft. That way I know when the floating sheave gets put on it, there'll be some oil between them. This is your oiling point on the motor. You need to oil this every 5 hours, Shopsmith says. The other oiling point is the control sheave at the top inside your headstock. So I've kind of double oiled it, worked it around, wiped it off. Now ready to compress the spring and its washer put the retaining clip back on. You can use the 2 clamp method to help you. If you're used to doing this, like I am, you can just go with brute strength. Again, be careful with that spring, it'll really come at you. Got to make sure that retaining clip is firmly in its groove. Clean that groove out ahead so there's no gunk that could cause it to slip. So everything rotates good.